So we have an obtuse angle. That one's pretty, those are easier than when the angle's acute, as we saw earlier. So we have the obtuse angle, B is 11, A is 20. Now you don't necessarily have to draw a picture. If you can remember, and think of it in your head, it just always helps me to draw a picture. Okay, but B is 11, A is almost twice as big. Okay, so in this case, how many solutions do I have? I have one. That's the only triangle I can have with those dimensions. Okay, so here's another obtuse. This one I actually want you to try. So try this. Pause and try that one. All right, good job. I know you tried it, right? Okay, so again, I have an obtuse angle, 110 degrees. B is 10. Okay, so here's B, and A is 15. So it's not twice as long, but it's still longer than B. So it probably comes down something like this. So that is one triangle again. Okay, we come over here, and now we have an acute angle. So I'm going to make that angle 63 degrees. Okay, and who knows how long that's going to be. And this is not to scale, so just keep that in mind too. All right, so 63 degrees. And B is 12, and A is 7. Okay, so it's smaller than B, but we've got to know what the height is. Okay, so this is where the trig comes in. So in order for me to figure this out, how many triangles I have, I've got to figure out what H is. So here's H. There's my angle. And it's the opposite over the hypotenuse. Sorry, I know that H looks like hypotenuse. It stands for height. Maybe I should use an X instead. But this is the sine of 63 degrees is my height over my hypotenuse. So 12 times sine of 63 degrees is my height. So if I throw that in the calculator really quick, I get that the height is 10.7. So this is 10.7. Well, A is only 7. So I've got this little dangly thing hanging on there, and it's just kind of swinging. It can't close up this triangle. So in this case, there is no triangle. All right, so I want you to try this one. I don't know how long this video is. Hang on, I'm going to stop and we'll try this one on the next one.